Hello everyone. Today we are going to discuss the 20 questions that I had posted in the last video. And I guess if we are thorough with these 20 compounds and their names, we would be good with coordination compounds as well, right? So first thing first, we need to know this chart. So those who are new, who are watching this for the first time, please make sure to refer the previous video on coordination compounds. I'll link it below. Okay, where nomenclature and the basic steps of going through the nomenclature are discussed. These are the 20 questions and I hope you all might have at least tried. Now, there's one key over here. I'm deliberately going to make one mistake, okay, one error in the nomenclature of these 20 compounds. Let's see how many of us can find it out. Okay, let's begin. So for starters, I've already calculated the oxidation state of each metal and I have kept it ready so that we can focus only on nomenclature and not utilize time on calculating the oxidation state. Again, if you are doubtful on how to calculate oxidation state, please refer to the previous video and you will be good with it, right? So let's see how this compound is going to work. First of all, let's start with ligands. There are 6 ligands. 6 meaning hexa. Hexa what? NH3. We know what is that. Amine. Then look up. It's chromium. If you see the charge, it's positive, right? So chromium retains its name. Chromium. Need to put the oxidation state in numerals. And finally, chloride. Irrespective whether 1, 2, 3, 100 chlorine atoms outside the coordination complex, you need to just give a general name, chloride. Let's see the next one. Over here, we have 2, right? So we know one thing, En is what? It is basically ethylene, 1, 2, diamine. See, the amine over here is different. It's NH2, okay? And how does this look if you want to know? It's CH2, NH2 joined to CH2, NH2, okay? And next we have Cl standing for chlorine. It is chloro. Now we know C comes before E, so we start with chlorine. Okay, how many chlorines do we have? 2. So it becomes dichloro. There are 2 ENs, right? But whenever you write anything in parenthesis, this is called as what? Parenthesis or your brackets. Ethylene, 1, 2, diamine. Rather than writing bi or di, you're going to go for bis, tris, tetrakis, etc. Okay, so only for the bracketed compounds you need to put this. And finally, we have what? Cobalt. If you see the charge outside is plus, so we need not make it cobaltate. Cobalt what? Cobalt 3. Okay. Let's see the next one. I'm sure you might have solved this. So we have got 4 times NH3, 4 times again. Tetra, NH3. Amine, correct? Then what? Platinum or platinate. Okay, it is going to be platinum because positive. Platinum 2. Platinum 2 what? Platinum 2 sulfate. Okay. Let's try the next one. Again, we have multiples over here. NH3 is amine. H2O stands for aqua, water. We know amine comes alphabetically prior to aqua. So we start with amine. How many amines? 4. Tetraamine. How many water molecules? 2. Diaqua. Okay, let's see. Copper is in positive state right now. So we put it as copper only, no cuprate. Copper 2 sulfate. I hope you're simultaneously checking your sheets for solutions. Okay. Next one. Hexa. What is that? Aqua, right? H2O is aqua. Again, +3. So we keep iron as it is. No need to form ferrate. Iron 3 chloride. It's a suffix anion, so it should always be named at the end. Let's go over here. We have two. One is NH3 and NH3 is amine. Another one is Cl. Cl is chloro. So alphabetically, amine should be named first, right? How many amines? 5. So it becomes pentaamine. Pentaamine. You can write monochloro or only chloro. Okay, you can put it as chloro. Again, plus, it's a cation, so you need not change cobaltate. It remains as cobalt. Cobalt 3. Cobalt 3 what? Chloride. No matter if it's 1, 2 or 3 chlorines. You put it as chloride. Let's check the next one. Okay, NiCN4 2 minus. Okay, so 4 ligands meaning tetra. CN, by now it should be clear, it's cyano. Now, 2 minus, negatively charged complex. Metal turns metallate, nickel turns nickelate. Nickelate 2. You can put it as iron, no problem. Okay, let's go over here. Starting 2 times NH3 meaning diamine. Again, positive. So we put it as silver. No need to make it arginate or argentate. No need to make that. Okay, you need not make it as argentate. It is only argentate if the complex is negatively charged. Here we can see the positively charged species, right? So you simply put it as silver. Silver what? Silver 1. What? NO3. See over here. NO3 is what? Nitrato. But that is what? That is basically in the ligand form. Here simply NO3 outside. So it becomes nitrate. Okay, like in the previous example, we didn't write chloro, right? We wrote chloride. Similarly, nitrate directly. No need to make it nitrato. Okay. That's only for ligand specifically. Again, we have two. One is H2O, which is aqua. Then we have Cl, that is chloro. Let's try to find out, right? So how many aqua do we have? Alphabetically, aqua comes first. Tetra, aqua, dichloro. C plus charge, complex is positive. No need to make it into 8. You can keep it as chromium. Chromium what? Chromium 3. You can put it as iron if you want. Okay, next one. We have, now again, we are going to name it as ethylene. En is what? Ethylene 1, 2 diamine. Ethylene 1, 2. Whenever parenthesis comes or whenever such brackets come inside a complex nomenclature, what you're going to do? You're going to give it bis, tris, tetra, tis. So this is 3, right? So it becomes tris. Okay. Now, positively charged complex. So cobalt stays as cobalt, does not become cobaltate. Cobalt 3 chloride. Cobalt 3 chloride. I hope you are checking simultaneously. Wherever you feel you have a doubt, please make sure you stop for a minute, retrospect, and try to understand where you're going wrong. Okay, next one. Again, we have En. We know how to name En now. Bracket ethylene 1 comma 2. Some people argue, like, can we write ethylene diamine directly? Yeah, you can write it. 1 comma 2 is what I prefer. Okay, that's why I write it. 2, right? So it becomes bis. Okay, bis what? Again, positively charged. No need to make it cuprate. Keep it as copper. Copper charge would be 2. Correct? Next is FeCN6. Okay, CN6. 6 meaning hexa. Cn is what? Cyano. Now, 3 minus negatively charged. We can't write it as iron. We write it as ferrate. See, ferrate. Ferrate what? Ferrate 3 iron. Okay. Next one. Again, we have NH3 and Cl over here. NH3 is amine and Cl is chloro. Okay, so amine comes first alphabetically. So it would go as 2 amines, right? Diamine, tetrachloro. Tetrachloro. Let's see. Is there any charge? Positive, negative? No, nothing. So metal remains as it is. Platinum, no need to make it platinate. Platinum, platinum 4. You can put it as iron. I specifically would say if there's a 0 charge, no need to put it as iron. Okay, next one. We have 2 over here. We have NH3. We have water, H2O. NH3 is amine. H2O is aqua. Amine comes before H2O, that is aqua. So we start with amine. Triamine. Triaqua. Okay, positively charged. Okay, no need to make it cobaltate. It remains as cobalt. Cobalt what? What is the oxidation state? 3, cobalt 3 chloride. I hope by now your nomenclatures are pretty done. Okay, next one, shallow. Okay, we have 2. We have En, which stands for ethylene 1,2-diamine. 1,2-diamine. And then we have C2O4 after a long time. Oxalato. Oxalato. If you want, you can find it over here. -2 charge. What is it? It's oxalato. Okay, let's see. E comes before O, so we need to start with E. So we start with ethylene. 1, 2. Diamine. Okay, and what will be over here? 2 times, right? So bis. Finally, no need to write mono. You can directly write oxalato. See now, is there any charge over here? No charge. So nickel stays as it is, right? Nickel what? Nickel 2. Okay, next one. Again, we have 2 ligands. We have NH3, amine. Then we have Cl, that is chloro. Right? Amine comes first alphabetically. So let's start with it. 4 amines. So it becomes tetraamine. How many chloro? 2 chloro. Dichloro. Tetraamine dichloro. What is the charge? Positive. Hooray. Chromium does not become chromate. So chromium. Chromium oxidation state 3 and CNO2. Now here, I want you to remember something. If we have NO3, generally we prefer with going with nitrate, okay? But whenever we have NO2, we are going in a different format. Okay, you can, many people assume it to be nitrogen dioxide. You can definitely call it as nitrogen dioxide. There is no problem. But whenever we write this, we are going to name it as, nitrite. Okay, so NO3 nitrate, NO2 nitrite. Okay, let's go ahead. We are coming to the end. Okay, we have EN. We know what's EN, right? Ethylene. I hope you're simultaneously checking in your notebook. Do not start this lecture without attempting the nomenclatures. Bis, what do we have over here? Positive, hooray. It stays as silver. Right, silver what? Silver 2, rare, very rare. We find silver 1 more in, in our surrounding. We don't find silver 2. Silver 2 is very rare. So we have got a rare compound. And we have bromide. Next one. CN6. So hexa, cyano. Now, minus charge, right? So it becomes ferrate. Not iron, ferrate. 2 ion. Okay. Next one. We have got NH3, NH3 again. What do we know it as? Amine. And then we have Cl. Cl is chloro. Right. So amine comes first alphabetically. We go for pentaamine. Pentaamine. Monochloro, you can put it as that way, or directly you can write chloro. Positively charged complex. So cobalt stays as it is. No need to make it cobaltate. Cobalt 3 what? Sulfate. Cobalt 3 sulfate. Next one, we have 2. We have NH3 over here. We have H2O. NH3 again amine. H2 is going to be aqua. Amine comes first, right? How many amines? 4. Tetraamine. Diaqua. Cu, right? Copper. Positive. No need to make it cuprate. You can keep it as copper. Copper 2. 2 what? Sulfate. Right. I hope you have understood the nomenclature with these 20 compounds and even the compounds we had discussed before. Okay, with this, we stop our nomenclature series. In future, we would try to incorporate nomenclature from competitive point of view, competitive exam point of view, but from both point of view, practicing so many nomenclatures are more than enough. Okay, meet you next with VBT series, valence bond series. Till then, signing off. Bye.